This is Algebra 1, Lesson 4.1, beginning of graphing equations. We're looking at coordinates and scatter plots. Make sure everybody understands how to do that. We're drawing plots in a coordinate plane, or we're plotting them. And then we're going to draw a scatter plot to represent real-life situations where we can see what's going on, beginning on page 203 in your textbook. We got a handful of definitions to start. A coordinate plane, when you see this term, it's formed by two real number lines that intersect at a right angle. This is a coordinate plane. That's a coordinate plane. It separates it into four different quadrants. This is quadrant 1. This is 2. We'll talk more about this later. This is 3. And this is 4. It's always written in Roman numerals, and it always goes like this. That's because of the way angles open up. You'll see that in a couple of years when you get to advanced math. But all you got to know right now is the coordinate planes when you draw a plane. Okay, an ordered pair. Each point in the coordinate plane corresponds to an ordered pair of real numbers. This is a plane. This point, 1, 2, 3, 1, this point, its ordered pair is 3, 1. Its x value and its y value. The ordered pair is that point on the real number plane. The x-coordinate is the first one. If you get confused, which one is first? A point is x comma y. The x1 is the first one. It's alphabetical. A, B, C, D, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, Z. X comes first. That's why you won't forget it. X comes first. The y-coordinate is the one that comes second. Again, x and then y. X, Y, Z. Y comes second. X coordinate, Y coordinate. The graph is the point that corresponds to an ordered pair. So again, 3, 1 from a second ago, 1, 2, 3, 1. This ordered pair is 3, 1. This point right here, though, is the graph. What most students don't understand is they think the entire plane is the graph. The plane is the plane. Just that point, that visual representation of the number 3, 1 is the graph. That is the graph. A scatter plot is a plot that represents real life situations like height and age, or so on and so forth. There's a lot of different things you can do. But the taller somebody gets, the older they are, or so on and so forth. A scatter plot will have a whole bunch of different dots on it. We'll look at them in a few minutes. It may or may not represent a correlation between the two things involved. In this case, it would be height and age. Here's example number 1. Plotting points in a coordinate plane. Plot these points. -2, 3, 3, -4, and 0, -2. Remember, for all of these, x comes first, then y. X comes first, then y. X comes first, then y. Alphabetical. The first one, -2, 3. You always begin at the origin. This is the origin, 0, 0. -2, remember your negative numbers are here. Tells you to go left twice. Left twice. +3, positive numbers are up. Tells you to go up 3 times. So -2, +3 is right here. That's the graph of the ordered pair -2, 3. Begin at the origin. Left twice, up 3 times. The next one, 3, -4. 3 tells you to go right. Your positive numbers are this way. To the right 3 times. -4 tells you to go down 4 times. Your negative numbers are here. To the right 3 times, down 4 times. And the last point you had to do, 0, -2. 0 tells you don't go left or right at all. It's 0. -2 tells you to go down twice. Here's your point here. Again, begin at the origin. X tells you go left or right first. Y tells you go up or down second. Here's a checkpoint. It says plot the points on the same coordinate plane. Take about 1 minute and do that real quick, and then we'll graph them together and see if you got them right. Okay, so let's take a look at it. The first one, -3, -2. X is first, Y is second. -3, -2 would be right there. The second one, 4, 0. X is first, Y is second. Go to the right 4 times and don't go up or down at all. The next one, 1, 4, tells you to go to the right 1 time and go up 4 times right there. And the last one, -3, 2, tells you to go to the left 3 times and to go up 2 times right there. So how far your points should be. If they're in a different spot, check and see if you can figure out what you made a mistake on. You might have gotten your X and your Y mixed up. You might have gone up when you were supposed to go down or left when you should have went right. Example number 2 is making a scatter plot. It says the number of NCAA men's college basketball teams is shown in the table. This is from years 95 through 2000. It says draw a scatter plot of the data and describe the pattern of the number of men's basketball teams. Let M represent the number of men's teams. Let T represent the number of years since 1995. It says because you want to see how the number of teams changed over time, put T, time, on the horizontal axis and M on the vertical axis. Then it says choose a scale. Use a break. Here's a term right here, break, in the scale for the number of teams to focus between the numbers 800 and 950. Your smallest number was 866 was actually smaller. 65 was smaller. So between 800 and the largest number is 932, so 950. So they just chose a number that was smaller than 865 and a number that was larger than 932. So if we plot the points, here is your break right here. You see this little squiggly line? Because your scale is counting by 25, 800, then 825, 850, 875, so on and so forth. But between 0 and 800, it's missing. So that's what a break represents, all that stuff that's missing. Your scale on the bottom counts by single years, 1, 2, 3, all the way through number 7, all the way through 7 years. So your plots look like that. So at 0 years, there were 865 teams or whatever it was, 66, 68, and then 866, and then 865. It went down a little bit, then it started going up to 895, then 9, whatever. So it looks like that. So from the scatter plot, you can see the number of men's basketball teams in the NCAA was fairly constant. Here's a term you could look at, you can use to describe things, fairly constant, because it kind of looks like it's going that way. Kind of like that. It's kind of going up as every year goes on. For 3 years, it went down constantly, and then it started to increase gradually.